Now I'm going to do example 2. This example deals with bearing and how to use bearing with degrees in different angles. So a ship leaves port at noon. We have port here at point A and heads due west at 20 knots or 20 nautical miles per hour. At 2 p.m., so from noon to 2, so they went 2 hours, they were at point B and they changed course. Here's where we have some bearing angles. What this means is what the ship did is he looked straight north, turned towards the west 54 degrees. So it's all marked in the picture, but that's what that means. If you look north and then turn to the west versus turning to the east, 54 degrees. So what that allows you to do is give a direction instead of always starting at the starting side, which would be looking this way. You can look north and then look east or west. Find the ship's bearing and distance from the port of departure at 3 p.m. So we're looking, the ship is here, we're looking for line C. So what I want to do is, again, try to use the idea of right triangles and see if I can use SOHCAHTOA and figure things out using the right triangles that are in the picture. So I've got a couple right triangles. I've got the big one, and then I've got this small one. And I think what I'm going to do to start with is, let's see, I'm going to fill in a few different labels. This angle, or this B, where the B is, that would be a right angle. I'm wondering if I can find, maybe looking at this little triangle, if I could find some more information here, like maybe this angle right here, 90 minus 54 would give me that little angle. That would be 36. Now if I look at this little triangle here, I have an angle and I have a side length. So they do have B and D labeled on the graph, and so I'm guessing it would be nice to know those eventually. So I'm going to go for those. I'm going to go for B first. I'll use sine of 36 equals opposite over hypotenuse, and I'll get side length B. 11.76, and then I'll go for D. Cosine of 36 equals adjacent over hypotenuse. And D is 16.18. So 16.18 and 11.76. So I'd like to find this angle here. It will help me find the ship's bearing from where it started to where it stopped. And now that I know that, I can figure out this whole side length here by adding 16.8 plus 40. That 40 is already marked. So the whole side length is 56.18. So I can find this angle here. I'm going to label it theta by doing tangent of theta equals opposite over adjacent. And I'm going to inverse tangent that fraction to get that angle. And it looks like that angle is 11.82 degrees. 11.82 degrees. So what I would do is I would say that this ship's bearing is, if I were looking north and I had to turn my head towards the ship, 90 minus 11.82, I have to look north 78.18 degrees west in order to see the ship. So that would be the ship's bearing to where it's at. Now I need side C, and I'll just get that using, I'm going to do SOHCAHTOA, you can use Pythagorean's theorem. So sine of 11.82 equals opposite over hypotenuse, and I'll get C. So side C is 57.41 nautical miles.